The question is to compare which is bigger, 1.01 to the 100th power or 2. Some students might say 1.01 is way too small. Even if you multiply it 100 times, raise it to the 100th power, it still shouldn't be bigger than 2, right? So 2 should be bigger, right? But you can't just guess. Everyone, you can't just guess in math. Let's analyze this carefully. Now, this 1.01, right? It's 1 plus 1 over 100, right? Isn't that what it means? Right? 1.01 is just 101 over 100. If you turn it into a fraction, isn't it 1 plus 1 over 100? Now, if you multiply it 100 times, let's see what happens when you multiply it 100 times. Let's break it down a bit more. Multiply it 100 times. 1 plus 1 over 100. Multiply it 100 times. 1 plus 1 over 100 multiplied 100 times. So compared to 2, which one is bigger? Let's break it down and take a look. So seeing this form, some students might ask, what's the point of rewriting it this way? Well, if you often do math problems, when you see this kind of form, what does it remind you of? The expansion method. It's often used in math competitions. When you see this kind of fraction, especially with a plus 1 inside, you should definitely think about expanding it. So how do you expand it? Pay attention. You add 1 to each denominator, starting from the second term. So for the second term, 100 becomes 101. For the third term, 100 becomes 102. And for this one, it would definitely be 1 plus 1 over 103, right? And you keep adding like this. Up to which term is this? The second term adds 1, the third term adds 2. So what about the 99th term? Wouldn't it be adding up to 198? Why are you confused? The second term adds 1, so by this point, isn't it adding up to 199? Why do we add like this? Because some students have questions. Why do we add this way? Because when you add like this, the terms in this expression can cancel each other out. Let's analyze how they cancel out. If you make all the denominators larger, the fractions themselves get smaller. So doesn't the whole expression become smaller? When the denominators get bigger, the entire expression gets smaller, right? So overall it becomes smaller, doesn't it? That is, compared to the original. If it gets smaller, then shouldn't the original expression, this thing here, be greater than this whole big chunk? So how much is this big chunk equal to? Why do we add it like this? Let's analyze it. The first term is 1 over 101, right? What about the second term? If you multiply, isn't it 101 over 102? Right? And what about the third one? It's 101 over 203. And the fourth one is 101 over 304, right? So this logic just keeps adding up. And after you keep adding, what does it become? What does this turn into? 198. This is 198, right? Over 198. Then it's 199, and the last one is 200 over 199. This is why we expand all the denominators by 1, because when you multiply like this, things can be canceled out, everyone. Right? This is often used in math competitions. See, it gets canceled out, doesn't it? Everything gets canceled out. The 198 gets canceled. The 199 gets canceled too. So what do you find it equals? It's exactly equal to, everyone, 200 over 100. So in other words, it's greater than this amount. And this amount is exactly equal. So it should be greater than 2. Do you understand this reasoning? This problem is quite difficult, and you really need to learn this method.